to solve a 3 by 3 system of equations. That's why we practiced the 2 by 2s for a while. Here's the first example. That's the initial problem. So you're going to have an x, a y, and a z in each of these three equations. And your goal in this is to do the following. You want to wipe out this position, and this one. You want to eliminate those so that when you can go down to here and solve easily for a variable, and then plug that variable back in and solve for y, and then plug both of them back in and solve for x. Just like we did with 2 by 2s, we eliminated the first two spots. We're going to be doing that here, but then we're going to have to eliminate this spot as well, so it creates a wedge formation like that. Here's how you do it. We're going to concentrate on those two numbers first, 5 and negative 2. What should I do to get those to be the same number? 2 and 5, right, because we want a 10 in there in each spot so we can get rid of it. So we multiply them by 2 and 5. So go through the middle one, multiply by 2, bottom one, multiply by 5. Now if you make a mistake in your multiplication from the beginning, it's going to throw the entire problem off. So there's what you end up with when you multiply the second one and the third one by 2 and 5. So this should have been 10 minus 12 y plus 4z, then equals a negative 44. Then on the bottom one, negative 10x minus 5y minus 15z, and then equals 25. Now if you have that up to this point, you're doing good, and it's no different than the 2 by 2 so far. Now if we have a positive 10 and a negative 10, what should we do to get rid of those? Yeah, we're going to have to add those together. So there's the two equations we had from the middle. I just wrote them separately. It's the same thing as what was on the last screen. We're going to have to add them together. And when you do that, you should end up with a negative 17y minus 11z equals a negative 19. What you have to do is hold this. If you understand eliminating those two spots so far, once you get this equation, you've got to write it off to the side somewhere separately and keep it, because we're not going to do anything with it just yet. We're going to go back to the original problem and do the same thing we just did, except with two different equations. We can't use the same two. So is everybody with me so far how to get this one right here? We knocked out those two on the side, made them 10s, added. That's why they're gone.
You always look at the bottom?
Yeah, start with the bottom two. You don't have to, but we are, so that if anybody makes a mistake, we can all be on the same page, and we can spot it real quick. If everybody did something different to start with, it'd take forever to troubleshoot. Alright, so like I said, hold this equation for now, and we're going to go back to the original problem. So there's the original problem, and notice that we used this one and this one to start with to come up with that new equation. We can't use 2 and 3 yet, or again here, because we'd get the same result. So since we used those two to start with, let's go ahead and choose a different pair. And how about the top two? So if we choose the top two, what are we going to have to make those x numbers into? 15. So what would we multiply by? 5 and 3. We would multiply by 5 here, and then 3 here. So that's what we're going to go work with next, and I'll put that on a different sheet so that you can see it. So there's those two equations. The top two from the original problem. Multiply the top by 5 and the bottom by 3. On the top, you should come up with 15x plus 15y minus 5z equals 165. And then on the second one, when you multiply by 3, you should come up with 15x minus 18y plus 6z equals negative 66. So we have a positive 15, positive 15. What operation will get rid of those? Minus. So we have to subtract both of those. So when we do that, we're left with 33y minus 11z equals 231. Now, just like we did with that last one, we had to hold that one and put it off to the side. So that's what you're going to do with this one. So we've generated two new equations. And with those two equations, we're going to go back and replace the bottom two in the original problem with those two equations that we came up with. So we're going to hold this and go back to the original, just like we did before. So there's your original problem. And remember the two equations we just created that we said we had to hold off to the side. The first one was this one, and the second one was this one, the one we just found. So together, they're going to look like this. So those two equations are going to replace the bottom two in the original problem. So there's the original problem again. And these are what are going to have to go. These will have to leave. That one's leaving. And that one is too. So here's the new one. So we replaced the bottom two with those two new equations that we have now. Now, you're going to do the same thing with these two equations that you do with any other ones that we do, where you have to eliminate a variable. Now, you have negative 17 and 33 out on the left. Those are going to give you some large numbers when you multiply them together to figure out what the common multiple is. So if we work to eliminate a variable in there, we want to make a smart choice because there is something that pops up here that's going to make it easier. You could do those two. There's an easier way. Can you see the easier way in there without having to use the y numbers? It doesn't work in all the problems, but in this one it just happened to come up. It's what? I can't hear you. Z? Yeah, the z ones. Yeah, because look, you have negative 11, negative 11. They're already in place. So you wouldn't have to do anything except pick the operation you're going to use to get rid of those. So if the signs are the same, what do you have to do? Signs are the same, you have to subtract. Yep, they're already the same. So the operation is subtract. So subtract those two equations, and here's what you come up with. The minus 11z's cancel out, and look how neat it works out. A negative 50y equals negative 250. So that's going to divide fairly evenly. So negative 250 divided by negative 50, and your answer is 5 for y. And once you make it to that first answer there, the y equals 5, it's all downhill from there, because all you do is plug it back in and solve for a variable. So you just found 5 and replace that bottom equation with y equals 5. So there's your wedge formation. From there, plug 5 in there and solve for z. And once you have z, you can plug y and z back in there and solve for x. You're just working your way back up the problem. So now let's solve backwards. So plug the 5 into y in the equation above it. And so you have negative 17 times 5 minus 11z equals negative 19. That's a negative 85 on the left. And move it to the right and make it plus 85. You're just solving a simple equation. Simplify that right side. Negative 19 plus 85 is 66. And divide the 66 by negative 11. Your answer should be negative 6 for z. So here's the original again. Once again, you're putting this one into there, and we found z to be equal to a -6, so you're going to put that in here and solve for x. So there's 5 going in and -6. Simplify to get 15 and plus 6 from a double negative. Add those together to get 21. Then 33 minus 21. That's going to be a 12. And then divide it by 3. And the answer is 4. So your final answer is written x, y, z. 4, 5, and -6 would be the final answer.